We need to wrap up carbonic anhydrase, and there are still some questions that linger with that case, so we'll review those. Remember, what we're looking at with this case is this take-home point. Whether a chemical reaction occurs spontaneously depends on its delta G. Delta G of a reaction can be changed by changing the concentration of substrates or products. That's really what we're going to be thinking about when we get into these questions 9 and 15. Okay? And enzymes can't change the delta G of a reaction. Now they can change the transition state energy level, and that's what we're going to look at with number 14. But they're changing the rate of the reaction, not the overall thermodynamics of that reaction. You've seen these before, so I don't want to take time with that. Actually, before we do this, I want to start with a top hat question based on something we did last time. So go ahead and get into top hat. Okay, so I'll flash back to PowerPoint in just a second. Here's the question. Of the 4 reactions that are shown in that equilibrium that we've been looking at for a couple of days now, which ones are catalyzed by carbonic anhydrase? 1, 2, 3, or 4? And you should pick all that apply. Oh, did I not open it yet? Can you answer it? Okay. It will only let you pick one? Hang on. Okay, now try. Now it should let you pick more than one. All right, and so the reason I'm asking you this while you're responding is that last class I asked you this. In the diagram of an osteoclast, why is carbonic acid not shown? Some of you said because the enzyme carbonic anhydrase is breaking it down very quickly. Is that true? Some of you said carbonic acid is not shown because it ionizes immediately. Okay, so let's think about these two answers, two quite different answers. And the question I'm asking you on top hat now, which of these reactions, 1, 2, 3, 4, is catalyzed by carbonic anhydrase, will help you decide between these two. Okay? All right, I'm liking what I'm seeing. So I want to come back to PowerPoint just a minute. So what's wrong with the top answer? Somebody hold up your folder and tell me. What's wrong with the top answer? I heard somebody back there. Go ahead, Parma.
Basically, the carbonic anhydrase is only working in 1 and 2 because carbonic acid is ionizing in water, and carbonic anhydrase is no role to play in that.
And what was the last thing you said? It doesn't play, carbonic anhydrase doesn't play a role in that? Okay, all right. So what Aparna has said is this is ionizing in water. Carbonic anhydrase is working on number 1 and 2 on these steps. And it doesn't play a role in 3 and 4. Let's see if you all agree. Good. All right, now I want to point out something. So most of you said 1 and 2. There you go, changing. All right. Stop. Now, a lot of you are thinking about this on the right track, but a lot of you are doing something that, or some of you are doing what is very common in biochemistry, to think that carbonic anhydrase is only catalyzing this forward reaction, the conversion of CO2 to H2O. In fact, it works in both directions, and hopefully questions 9 through 13 helped you think about that. But you may have been surprised to learn that during the case, but that is true. So these enzymes that we're going to be studying throughout the semester are usually working in both directions. Now there are some exceptions to that, but usually working in both directions. All right? And how they work is going to depend on the delta G of the reaction, right? So they're just controlling, carbonic anhydrase is just controlling the rate. The direction in which it's working to control that rate depends on the overall delta G of the reaction. All right, good job. So our best answer here is this one. Carbonic acid is not shown because it ionizes immediately. And that's true. This 3 and 4 is not catalyzed.